Now, if you've completed the first worksheet with the first lesson, you should have proved these two yourself. However, if not, let me show you. With a triangle labelled with an angle theta, and I'll label that side A, that side B, and that side C, then we know that the sine of theta is equal to the opposite over hypotenuse as shown. The cos of theta is equal to the adjacent over the hypotenuse, and the tan of theta is equal to opposite over the adjacent. Now, if I was to look at that division as given, sine theta divided by cos theta, well, sine is that fraction divided by cos is that fraction. And if I use the knowledge that to divide by fraction we invert that fraction, change that sign to a times, then we can see that those c's cancel, giving you a divided by b, and a divided by b is tan. So you can take it as written that the tan of an angle will always be the sine of the angle divided by the cosine of the angle. Now for the second one. For the second one, we need sine squared. So there's sine. So sine squared will be that squared. And cos squared would be that. Now they're both over c squared, a squared plus b squared. However, a squared plus b squared is c squared, Pythagoras' theorem. So those two on the top can actually be replaced with c squared, and c squared over c squared is 1. So therefore, sine squared plus cos squared equals 1. But we don't tend to write it like that. And if I was just to take the brackets off, it does look as though I'm squaring the a, whereas really I need to work out sine a and then square it. Hence, that's the notation that we use if we're not using the brackets. But again, you can just take that, what we call trig identity, as written. Just as you do for sine, cos, tan, you can now just quote those two formulae. Again, this bit only makes sense if you've completed the first lesson's worksheet, and that is on a construction of a triangle. What you actually find is that the information given provides you with two triangles with that same information. We call it ambiguity. If you type into your calculator the sine of 30, which we know is a nice answer of a half, then if you type in the sine of 150, you'll find that that's also a half. In other words, thinking about the sine graph, which follows that sort of pattern, there are always two angles that come to one particular value. And we can use this result to establish the second angle given the first one, if the information allows us to. So answering this question, we can look to see whether or not we have ambiguity. So we're after finding that angle there. So I would quote the sine rule, that the sine of r divided by 8 must be the same as the sine of 80 divided by 9. So therefore the sine of r is equal to what I've just said, times by 8. Put that into the calculator. So sine 80 divided by 9 times by 8 comes out as 0.87, etc. So if we now do shift and sine, shift sine gives us an answer of 61.87 61.1 degrees. 61.1 degrees. Now at GCSE you would have stopped there. What you've got to check though is whether or not you can have the alternative. Well, from the previous setup, if I do 180 degrees minus 61.6, the other angle is suggesting this angle could be 118.9, though here that triangle, that information produces just that answer. We cannot have the other angle, we cannot have 118.9 because when it's added to 80 it takes you over the rule for angles in a triangle. Hence, no ambiguity here. That said, from now on you have to check whether you can have another angle, i.e. if that had been below 100, then yes, we could have had another angle in there. So here we have a triangle ABC. We're told that angle A is 45. We're told that AB is 12. And we're told that BC is 10. We are asked to work out the possible values for C and for B. So we can start by finding that angle using the sine rule. So what we have is we have sine C over 12 should be the same as sine 45 over 10. So the sine of C is the same as the sine of 45 over 10 times by the 12. If I put that into the calculator, it should come out as a 0 point. So we've got, as I've said, sine 45 divided by 10 times by 12 comes out as 0.848, etc. So the calculator produces an answer of 58.1 degree. From that, I'll be able to work out what B could be. However, there is another possibility. Because if I do 180 degrees, take that 58.1, I get 121.9, which is also acceptable. Why? Because the 121.9 added to the 45 is still below the 180 for angles in a triangle. So that means that C could equal 58.1, in which case B would equal the angle 58.1 added to 45, take that off 180, implies that B could equal 76.9. Alternatively, as I've already said, C could equal 121.9. So 121.9, when added to the 45, take that off the 180, B could alternatively have been 13.1. So that triangle did have ambiguity. Now, as for part B, which I'll answer here, for the area of the triangle, I can use this angle here. So I'm going to use that the area is equal to a half AB sine C. Another formula you should have done at GCSE. Now your A and your B, so to speak, are two sides, which I'm looking at these two because I know these two sides, 10 and 12. So half of A times B times the sine of the angle you know. So there are two possibilities because that angle could be that angle could be that. So the first area would be a half times 10 times 12 times by the sine of 76.9. Calculator working. Times 10 times 12 times sine of that angle. So that comes out as 58.4. Alternatively, the second possibility is that instead of the 76.9, it could have been 13.1, which produces another answer. So clearing the angle and putting 13.1 in its place, that produces an answer of 13.6. So there's the two possibilities for the area. So the next bit, you have met this before, you need to know the cosine rule, and if I just take that top one, you perhaps need to be aware of the rearrangement of this. If I put this over here and the a squared over here, then I get that cos a equals b squared plus c squared take a squared. You notice I haven't written the 2bc, because what I'm going to do now is the 2bc that should be at the front there, take that across, and it becomes a divide, 2bc. So that rearrangement is useful if you are trying to work out the angle. Okay, so quoting cosine rule, we have got that side, pt squared, should equal 7 squared plus 6 squared. Take 2 lots of 7 times 6 times by the cosine of 55. So we have 7 squared plus 6 squared, take 2 times 7 times 6 times cos 55, all tapped in one go. That comes to 36.8.
I just told my boy all this morning, I just said.
Thank you. So in order to answer this question, we're going to use the cosine rule. Now the reason why the cosine rule is used here is because there's only one angle mentioned. I'm not trying to find these angles, so only one angle is mentioned. So cosine rule. So this side, pt, so pt squared, will equal 7 squared plus 6 squared, 7 squared plus 6 squared. Take 2 times 7 times 6 times by the cos of the angle 55. Now all of that can be put into the calculator in one go. So we have 7 squared plus 6 squared, take 2 times 7 times 6 times cos 55 equals 36.8. So therefore PT equals the square root of that, because that's PT squared, so square root of that, which comes out to be 6.1 to 1 decimal place, but you could go to 2 as it doesn't tell you anything else. So far with the sine rule, cosine rule, it's just using your knowledge of GCSE, and it's how could they make sine rule, cosine rule more complicated for you. Well, here's one example of that. So here it's asking you for the area of the triangle, which you know is a half AB sine C, but I don't know what that angle is. So the first thing I'm going to do is find that angle. There's only one angle mentioned, so it's cosine rule. So I start with the cosine rule, which I write as cos angle is equal to b squared plus c squared, take a squared, divided by 2bc. Now, if you had not written it that way, if that 2 had been something different, i.e. the 3 or the 4, and therefore the 2 was one of these numbers, then accidentally you'll be finding that angle or that angle, not the angle that you've been labelled on there. Anyway, 3 squared is 9, 4 squared is 16, 2 squared is 4, so if you got the 9 plus the 16, take the 4, you've got 21. 2 times the 3 times the 4 is 24, and that can be cancelled because 3 goes into both numbers 7 times and 8 times. So we have an expression for cos of the angle. Now the thing is though, to work out the area, we require half of A times B times the sine of that angle. We don't know the sine of that angle. Now you've got two ways here. You could draw a right angle triangle and put the angle in there, or if I take you back to the early part of the lesson, I can use the fact that sine squared plus cos squared equals 1. So sine squared plus cos squared equals 1. So therefore, to work out sine squared, all I have to do is subtract the fraction from 1. So 1 take 49 over 64 gives me 15 over 64. So therefore, sine theta is equal to the square root of that, which is that. Hence, if I go back to the structure I had, I now know that that is the square root of 15 over 8. That is 6. So I'll tighten that up. 2 goes into both of those. 3 times and 4 times. There's an expression for the area. So another challenging question using the knowledge of your sine rule, cosine rule. Again, only one angle is mentioned, so I can use cosine, and I can say that 7 squared must be the same as that squared added to that squared. Well, that'll make it 9x squared. Take 2 times x times 3x times by the cos of 60, and the cos of 60 is a half. So that's 49. X squared and 9x squared is 10x squared. 2 times 3 times a half is 3, and x times x is x squared. So therefore 49 is the same as 7x squared, therefore x squared must be 7, so x must be the square root of 7. In order to work out this angle here, then I can use the sine rule and say that the sine of c divided by that, which we now know is root 7, should equal the sine of 60 divided by 7. So the sine of c is equal to the fraction I've just said, times by square root of 7. Throw that into the calculator. So the sine of 60 divided by 7 times square root of 7 comes out as 0.32, etc. Therefore c is equal to the shift sine of that, which comes out as 19.1. However, I need to check to see whether I'm allowed the other one. Now check for ambiguity, and if I do 180 minus that angle, I get 160. That 60 would take it over the 180, so there's no ambiguity here. That is the only solution for C.